Well, good. So we finally had a hard assignment? Huh? Well, they should all be challenging. But once you get to an assignment where like everybody feels it was difficult, then that's considered a hard assignment, right? Or like nobody feels like that was like a reasonable assignment. Yeah. Oh, finally we didn't hit it yet then. All right. So let's see. I just built the generic interface, right? And then I remember we were having some issues on width. Let me look something up here real quick. Um,
You just put it in the float. Not for percentage.
just 0.33
Yeah, 33.
for weight.
Weight, yeah. Layout weight.
So 33.33 like that.
Yeah, that's what it works. And then.
Oh, I just did that for. Oh no, I did that for that guy. So this guy should be 33.33, and this guy should be 33.33.
They won't behave right until you put something in.
Right. Well, these guys already have discs in there, so we probably need to have the width set to. We can have it set to wrap content, but that's. Can we have it set to fill parent for width? You ever see that? Oh, I did it for the wrong thing. Need to do it for the discs. It still makes them too big.
If you put elements in the other layouts, it will equal out.
I wonder if we say none. Oh, that's not good. We say wrap content, and then we say, oh, that goes height. Well, for starters, what I'm going to do is I'm going to set for the 3 towers, I'm going to give them gravity. Of bottom and center horizontally. Like that. Okay, so that'll make those guys look okay. That just break my weight for that guy? No, it's still set the same. It's very strange that those look that way. I mean, you're saying as soon as I drop a disc in one of the other ones, it'll lay out better. But I don't know, it's still strange. Okay. Well, whatever. We'll leave it like that for right now. And then we can doctor it up a little bit at the end. Okay. So if I go to my main activity, which is going to be the presumably the guy that's going to manage this whole thing, I need to give myself access to some of these widgets. All right. So I'm going to need the 3 discs. I need the actual, we're doing these guys as buttons. So I'm going to need the buttons associated with these 3 discs. And I name this disk 0, disk 1, and disk 2. Okay, let's go ahead and give myself access to those. So I'll give myself private button disk 0, private button disk 1, private button disk 2, and then we'll go ahead and give ourselves access to those. So this dot disk 0 is equal to, I know we don't have to do it like that, but I like to do it that way. This dot find view by ID, r dot ID dot button. Oh, I called it disk, right? Disk 0. All right, so that'll be the first disk. And then I'll do the same thing for the other two. This is disk 1. This is disk 2. Disk 1. Disk 2. Okay, so I have my 3 disks now. I have access to the visual aspect of those 3 disks. Now, when I go ahead and I create my disks, so now we're going to kind of marry them together just like we did with linked lists, right? So when I create my 3 disks, I want to go ahead and give them the visual representation of themselves. I'm not sure in the end whether a disk is going to have to necessarily change itself, but we'll go ahead and let a disk know about its interface. So this is kind of us doing our own MVC piece here. So I'll go ahead and create, so we decided a disk is a button. That's how a disk is represented. So I'm going to say private button disk visual, something like that. All right. Then when we build the disk here, we're also going to pass in the disk visual, the button along with that. And we'll say this dot disk visual is equal to whatever you passed in. All right, so we've expanded our disks a little bit to now also hold what they look like. All right, so back in main activity, we want to go ahead and we want to now create our 3 disks. We have the visuals that we're going to need to create those 3 disks. So I'm going to go ahead and say disk, we're going to have disk D1 is equal to new disk. And this guy takes in a size, so we'll have, well, we can choose whether we want to start it off at size 1, 2, 3 or 0, 1, 2. Let's just match it to what we said before. So this is going to be size 0. And then the visual will be this dot disk 0. So that's going to be our disk 1. Disk 2, disk 3. Okay, so with that in mind, let's go ahead and name these more appropriately so we don't give confusion. I'll name it D0, D1, D2 for disk 0, disk 1, disk 2. All right, so I got the visuals. Now I created the logic disks and let them know about each of their visuals. Okay, because those logic disks are going to be the pieces that are going to allow us to ask the question, is the size of this guy compatible with pushing him to this tower based on what the top of this tower, the disk that lives at the top of this tower is? That make sense? This guy will allow me to ask those questions. Okay, now we need to also have access to our towers. Now I'm going to actually go ahead and give myself access to the towers at the top here. The individual disks will live in the towers, so we'll actually get them as the game is going. We didn't need global access to them, and you'll see why here in a few minutes. If you wanted to put them up here at the top, it's not a deal breaker. But I'm going to go ahead and create a private tower T0, private tower T1, private tower T2. So now I have 3 towers, because Towers of Hanoi requires 3 towers. And we go back and look at our tower here. We wrote our tower as a simple stack, right? A stack of disk objects. All right, but it doesn't currently have the logic built into it for whether or not you're allowed to push a disk or not, right? We haven't put that in there yet. But what we're gonna create first here is just a functional interface where we can push and pop to our heart's desire, moving things from one tower to another, completely ignoring rules. All right, that's what our first step is going to be here. All right, so when I build this tower, now I also probably want to have a visual representation of my towers. And towers are represented in our world here as a view group, right? All right, so it's going to be a view group that has, when we pop, we'll be popping off bucket 0. When we push, we'll be pushing it onto, we'll be adding it at bucket 0. So we'll create a private view group. And this, what do we call it in disk? Tower visual. Tower visual. All right, so now when we build a tower, we're also going to have to take in the view group that is the tower visual. And we'll set this dot tower visual equal to tower visual, the guy that was passed in. All right, to give ourselves access to that. All right, so let's go do that piece now so we don't forget it, and then we'll come back in here and we'll modify our push and pop to also change the visual as we're going. All right, so let's go back to this guy. Let's click on our towers. So that's tower 0. We named him tower 0. This is tower 1, tower 2. So we have our 3 view groups. So down here, I'm going to go ahead and I'm going to give my, we actually did not need the buttons here. I'm going to, just to keep this relatively clean, I'm going to delete them from there. And I'll actually define them here as I'm creating them, because I use them to create the disks. So the actual buttons will be stored in the disk, so I won't need direct access to them up top there. Okay. Similarly now, I'll come in here, I'm going to create a view group for tower 0. And this guy will be the view group version of this dot find view by ID r.id dot tower 0, like that. And then I will similarly tower 1, tower 2. All right, so now I have the view group representation of my 3 towers. So now I need to create instances of my towers passing it the correct view group. So reminding us in a tower, constructor for tower only needs to know about the tower visual, which we now have. So now I'll go ahead and say this dot T0 is equal to a new tower, passing it tower 0, my visual. This dot T1 is equal to a new tower, passing it tower 1, my visual. This dot T2 is equal to a new tower, tower 2, my visual. So now I have 3 towers, and those towers are accessible up here. All right, so now I'm going to do one additional thing that's actually going to be fairly advantageous to us, and you'll see why here in a little bit. This isn't really required, but it will make life easier. I'm going to go ahead and up here, I'm going to create a private tower array. And my tower array is going to be a new tower array with 3 towers in it. This guy upset about it. Private. What doesn't he like? Oh, I need to give it a variable name. Towers. All right, so I'm going to create a tower array called towers, and that's going to be a new tower array with 3 towers in it. And then what I'll go ahead down here and I'll do is I'll say this dot towers at bucket 0 is equal to this dot T0. This dot towers at bucket 1 is equal to this dot T1. This dot towers 2 is equal to this dot T2. Now, we could probably make an argument right now as well that we actually don't need to have direct access to the towers up here, since tower 0 lives at bucket 0 of towers. Tower 1 lives at bucket 1 of towers. Tower 2 lives at bucket 2 of towers. So if we wanted to, we can probably move these guys down here, just like we did before, and say this is a tower. This is a tower. This is a tower. And we just load them into that global array down here. That we can get rid of these guys. All right. Now understand all those things we're doing there, all just comes down to organization of variables and where we have scope. It wouldn't be incorrect, it might be a little bit ugly looking, to have all of these variables we've defined here defined up top here. You then have access to them everywhere. Not the end of the world. But effectively what we've done here is we've encapsulated inside of a single array of towers all of the 3 towers. Now when we start our game, where are the 3 disks? They're in tower 0. So we need to, because right now they're separate, right? We have a tower. Now we know that visually out here, tower 0 has some disks in it, right? But we haven't actually added them to the data structure that is our tower. So what I'm going to go ahead and do is I'm going to, because we have access to the disks now, right? We have those guys. I'm going to remove everything from tower 0. We just used it to give us our buttons in case you wanted the buttons to look prettier or something like that. So they're loaded into the towers now. So now we're going to initialize our game. So the very first thing we'll do is we'll say this dot towers at bucket 0 dot. Now that's going to be an actual tower. So what we actually need to do is we need to tell tower 0 up here dot remove all views. So that guy will actually dump the 3 buttons from his collection. We're going to put them right back by pushing them onto that tower. Okay? But they've currently been dumped off of there. We still have them inside of our button variables up here and then inside of our disks up here. So we haven't lost pointers to those guys. We've just gone ahead and cleaned out that view group so that we can now push the 3 towers and the 3 disks rather in the right order back onto those guys. Okay, so now we'll go into tower. We actually probably are going to need the getter for our disk, since we made a private disk visual. So I'll go ahead and generate a getter for disk visual. So there's our getter. So now a disk can hand us the visual aspect of itself, because we're going to need that button when we add that to a tower's visual. Okay, so now we'll go back into tower. When we push a disk onto tower, no matter what happens here, whether we're putting it on the top here or we push it on top of what was there before, we are going to visually add the disk that we just pushed onto the tower to the top of that tower, right? So we'll say this dot tower visual dot add view at index. What view? The disk d dot get disk visual, and the index we're adding it to is 0. So that'll push that visual disk back onto the top of our visual for our tower. Does that make sense? So this is the data structure logic for us to, with our linked linear data structure, for us to add something to the top. And then here's us making our interface match up to that. Similarly, when we pop, so peak doesn't do anything with, it doesn't remove anything from the tower, it doesn't remove anything from the visual, so we don't need to touch peak here. But pop, when we're removing a disk for pop, we also need to make sure that we remove the visual aspect of that disk. I gave you a hint last time that you cannot have views that live in two containers at the same time. So if we forget to remove it from this tower here, even though we're returning the disk that contains that button, if we forget to remove it from this container, and then we try to add it to a different container in a minute, it'll break. Your program will crash because you're trying to have this button live in two different layouts, two different containers. So right before I remove, just to remove, in actuality, it's going to be the top. We're actually only going to do that inside of this if statement because we've decided that pop should always return something, including it might return a null, right? So the very first thing we did here is we said, we're going to go ahead and set disk to remove to whatever top is. Now remember, top, if we're dealing with an empty tower, top would be null. There's nothing in there, right? Because that's what we set top to when we created that empty tower. All right, therefore, only if disk to remove was not null, only if we have an actual disk that we're about to return, do we update top, update the disk we're going to remove, and then update our visual. This dot tower visual dot remove view at 0. That'll disconnect that visual only if we're actually removing a disk from the tower. That make sense?
Can we also put it in the placeholder here?
Put it where?
The placeholder. The view, the layout view, we need it as a placeholder.
Oh, we will, but we're not going to do it here. I'm just kind of mechanically doing this. So I'm going to say we're going to pop from that tower. So that might happen in main activity. Now I have a disk. So I'll say, was this actually a disk or was this null? Right? So if I actually have a disk, then what I'm going to do is I'm going to go ahead and I'm going to put this guy into my little placeholder space. And then I'm going to flip all my buttons for pushes instead of pops. That way I can go and hit one of my other buttons to then push it onto one of the towers. All right, so it all comes down to who's in charge of putting it into that placeholder. You could make this guy in charge if you wanted to, but I'm kind of treating them like objects, where I'm just asking a tower, I'm saying, pop, you give me whatever disk's at the top. And he's going to toss it out there like a football, and I'm holding that disk. And then I get to decide what I'm going to do with it. First, I'm going to look at it and make sure it's actually a thing. And then if it's a thing, I'm going to go ahead and put it in my placeholder so that I can now turn control back over to my user to decide where he wants to push it. Okay, so pop is going to grab the top of the list, or top of the stack, decide if it was a thing. If it was actually a thing, then it'll update the stack data structure and ultimately remove the visual of that from the top of the stack. And then ultimately we'll return disk to remove, understanding that this only conditionally happened if we actually had a disk to do something to. Okay, so now go back out to main activity. Now we need to go ahead and give ourselves, so now we can go ahead and we know how to push onto a tower, we know how to pop from a tower. Now we need to give ourselves buttons in our main interface for when to pop and when to push. All right, so I'm going to give myself 3 functions. So it's going to be public tower 1, or no, tower 0 button. Sorry, this is void. Tower 0 button pressed. This will take a view V as a parameter. Copy that. There's the next one. There's the next one. This will be tower 1. This will be tower 2. All right, so those are my 3 buttons there. Let me go ahead and hook them up, and then let's test our interface real quick and make sure that they're doing what they should be doing. And we're going to remember to make sure that our thing is hooked up in Logcat before we make some assumptions that it's not working. So I'll just do a system.out.println tower 0, and I'll put a bunch of asterisks before that so it's easy for us to see. Tower 1, tower 2. All right, this is just for testing that our 3 buttons are going to work. So we'll go back out to our activity main now, and we'll click on, here's our disk 0 button. We'll go to on click. Oh, thank you. Here's our pop button. We're going to set his on click to tower 0 button. Then we'll have this button, and we're going to set his on click to tower 1 button. And then we'll set the third one and set his on click to tower 2 button. All right, so now presumably when we click these 3 buttons, we should have a tower that does, well, we should get stuff printed out. So let's go ahead and launch our invalid key response. Let's kill it and try it again. Oh, this was the thing a lot of you were getting. Something broke in my, stopped my Gradle. So which guy did I set a bad weight for? Yeah. All right, so those guys are all good. So I must have had it for.
I just know that in your layout that like holds the 3 for some ones.
It's gonna what?
When I tried it, there were weights in a lot of places, so I just ended up doing
Oh, looks like for mine it was just in that one. from our testing last time. All right, so now let me open up my logcat, make sure this guy is connected. See, we would have that problem again. Then I'll hit pop a couple times. There's tower 0, there's tower 1, there's tower 2. Buttons are working. Okay, good. So now we need to, do we add them back to that tower? Oh, we did. Oh, we never pushed them back on. So back in our main activity here, after we removed all those views, we now need to push them back onto tower 0, because tower 0 is where those buttons should be. And we're going to push them in the order of disk 2, then disk 1, then disk 0. So we'll say tower 0 dot, that guy's a view group. So I'm going to say this dot towers at bucket 0 dot push. The disk I'm going to push on there is D2. Then I'm going to push D1. Then I'll push D0. And that should now re-put my disks onto tower 0. Because with push, we made a tower update its view. So there's my 3 disks. Okay. So now what we're going to do is we need to give ourselves access to this placeholder for the disk. And I put a button in there as your, but I'm going to go ahead and remove that button, but I need this container that he's in. All right, so this button lives right there, but here's the container. This is a placeholder BG for view group. And I'm going to go ahead and dump that button that I had in there. So it's not going to be there anymore. And then we're going to set each of those buttons when we pop for it to then add at bucket 0 of my placeholder that particular button, the disk that we just popped off, with the visual aspect of that disk. Okay, so we'll go back to main activity. I'm going to give myself a global variable here. So private disk placeholder. And this guy will start off as null. There's nothing in the placeholder at the beginning. All right. Then I'm going to give myself private view group placeholder VG. And inside here, I'll go ahead and give myself access to that. So I'll say this dot placeholder VG is equal to the view group version of this dot find view by ID r.id dot placeholder VG. All right, so now I have access to that placeholder. Okay. Now, whenever I pop something off one of my towers, I'm going to try to pop something off of a tower. I'm going to go ahead and give myself a private. This guy will return a disk. Actually, I don't even need him to return a disk. This guy will return a void. We're going to call this try to pop from tower. And this will take a tower index as a parameter. So all 3 of these buttons are going to call this one function, passing either a 0, a 1, or a 2 to this guy. All right, so the very first thing we'll do is we'll say disk temp is equal to this dot towers at bucket tower index. That is the towers is a group of tower objects. Okay. Dot. What does I want that? Oh, bad syntax. I was doing Swift the other day. All right, there we go. So this dot towers at bucket tower index dot pop. So I'm going to try to pop from that tower. Now this guy might return me a null. If there was nothing in that tower, I'm going to get a null from that. Okay, so if temp is not equal to null, that means the tower I just tried to pop from, in fact, gave me an actual, an actual disk. And that disk has been removed from that tower's visual. I will then go ahead and put that disk on the placeholder. So I'll say this dot placeholder is equal to temp. And then I'll also say this dot placeholder VG dot add view. I can just add the view directly because there's only going to be any one view in there. Or if you like it better, you can add it at index 0. So I'm going to add a view. What view? Temp dot get disk visual. That should visually put the button associated with that disk on my placeholder. And this is when I try to pop from tower. Then what I'll do here is in tower 0, I'll say this dot try to pop from tower 0. For tower 1, I'll say this dot try to pop from tower 1. And for tower 2, I'll say this dot try to pop from tower 2. Okay, so if we try to click on tower 1 or 2, we should see no change. We click on tower 0 in ours, because there is disks in there, we should see the disk get removed from there and put into our placeholder. We should also see the disk get removed in there for multiple times if we just keep clicking, because we're not creating any back and forth yet. So let's go ahead and test this. All right, so we'll go ahead and pop off of the first tower. And we got it up in our placeholder. Probably want to set this guy's gravity to center or whatever, but that's fine. Now I could just keep popping if I want to and just keep throwing stuff up there. That's not part of our game currently, but we see our interface doing its thing. So the next thing we want to have happen is after we pop something, we want all these buttons to change to say push. But then we also want their logic to change as well, right? So I'm going to go ahead and I'm going to create a private button array called tower buttons. This will be a new button array of size 3. So this is a good use of arrays. We know exactly how many things we need to hold, and they just happen to be indexed the same as we need them to be indexed. All right. So we have our 3 buttons. I need to go ahead and give myself access to those buttons now programmatically. So let's see if we name them something interesting. Yeah, we called it Tower 0 button, Tower 1 button, Tower 2 button. So we'll go ahead and give ourselves access to those. So we'll say this dot tower buttons at bucket 0 is equal to the button version of this dot find view by ID r dot ID dot tower 0 button. So in this case, I'm not actually putting them into an intermediate variable, so I'm just putting them directly into the array. You can choose which you like better, but this certainly wastes less space. This will be 1, this will be 2, this will be 1, this will be 2. All right, so I'm putting the buttons I found directly into the appropriate bucket in my array, as opposed to what I was doing before down here with the towers, where I stored them in 3 variables first, then put those 3 variables into towers. I could have just added them directly to the towers if I wanted to. All right. So now I have my 3 buttons. And what we're going to do here in the try to pop from tower, because only this logic here happens if something really got popped from the tower, right? So what I'm going to do here is I'm going to spin through all of my tower buttons and change the text on them to say push instead of pop. Make sense? And what I'm going to do is at the top here, I'm going to give myself a single flag. I'm going to say private Boolean. We're going to have this guy be should pop, and that'll start off as true, because initially the button should pop. Okay? So then in the try to pop from, so we just popped something. So we'll go ahead and we're going to say this dot should pop to false. We're going to flip it to the other one because we want to change the functionality of our 3 buttons in a minute. So we'll say this dot should pop to false. Then we're going to say for button B in this dot tower buttons, B dot, what is it, set text. Oh, I want it to be pushed this time, right? To push. So this is a for each loop that'll go through all the buttons inside of tower button. So I can write it this way, or I can say for int I equals 0, I is less than tower buttons dot length I plus plus, and then I can say tower buttons at bucket I dot set text to push. Or since I don't need the actual indexes, I don't need the 0, 1, and 2, I can use a for each loop here where each time through my button B will become the next button in that array of buttons. And then I'll just say b.setText to whatever I want it to be. All right, so now after I successfully pop a real thing, it should go through and set all the text on those buttons to say push. This is just visual. They're still going to work as pop buttons right now. All right, so let's test that. All right, so I hit the button. Now all my buttons there now say push. Okay, now what we'd like to have happen now is that when we click a button that says push, it doesn't pop again, because right now it's going to keep popping, right? So it doesn't quite do what we want it to do, but we're halfway there. Yeah, and that's okay. Yeah, I mean, and at the end of the, you're right, but who cares? You know, because the interface that we're making in here is more of a better than text interface. You know, I'll never mark you down for a less well thought out interface, because my interfaces are only marginally well thought out. So it just so happened I came up with this while we're on the fly here. I could have just as easily come up with some stupid solution. Who knows? All right, so now when I hit those tower buttons, I only want to try to pop if they currently say pop. And it just so happens that I don't have to look at the text. I can look at this Boolean and say, should I pop? So I'll ask the question, if this dot should pop, then try to pop. That makes sense? I'm going to go ahead and just steal this if statement for all these other ones, and then just change the numbers again. So we'll try to pop 1, try to pop 2. that means that there's going to be an else for these. So this guy will be else. If I wasn't, if it's not should pop, that means it effectively is should push, which means I should be removing something from my placeholder and putting it into my destination bucket, whichever guy I clicked on, right? So we're going to write a second guy here for try to push to tower. Private void, try to push to tower. And this guy will take in a tower index. Okay. And now this guy is going to try to push to the tower. Now we could always error check and make sure there's actually something in our temp or our placeholder. But if we're in this function, there should be. All right, so we'll just assume that we didn't make a mistake and we'll just not error check. All right, probably poor programming practice, but we got 23 minutes left. All right, so we're going to go ahead and we're going to say, now notice I'm saying try to push to the tower. Now right now we're going to go ahead and have it push to the tower regardless. But the try to push to the tower is going to be where we're going to be able to ask that question. Is the tower I'm trying to push this guy to, is he a legit tower to push this to? Make sense? I'll be able to peek at the top of that tower and look at the size of the disk at the top of that tower, compare it to the size of the disk that's currently in my placeholder, and say, is this allowed? That's where that logic will end up coming in. But right now, we're just going to let it happen so we can kind of mechanically move stuff around and not care about legality. All right, so try to push to tower. We're going to go ahead and we're going to say, we know the guy we're pushing is in our placeholder, VG. We definitely need to remove him from there. All right, so we're going to have, we already have our disk that's stored in placeholder. We have our placeholder disk. So we can just go ahead and empty placeholder VG. Because remember, the views cannot be in two places. So very important, we're going to say this dot placeholder VG dot remove all views. All right. Now we're going to try to push him to, well, we're going to, in this case, actually push him to the destination. When we come back and do this, we'll probably only remove the views if it's a legal move. But right now, we're assuming everything's a legal move. So now we're going to say this dot towers at bucket tower index dot push this dot placeholder. That's the disk we're going to push onto that destination tower. All right. Then we'll say this dot placeholder is equal to null. We'll empty that out. Then we'll say we need to flip the switch. So we'll say this dot should pop is back to true. And then we'll spin through our buttons. Change them all back to pop. So we'll remove our visual from the placeholder. Push that guy onto the tower that we chose to try to push onto. Zero out the placeholder, which actually probably isn't even necessary because it's just going to get overwritten in the future. But we're going to be, we're cleaning up our room. So we'll set it to 0. Flip our sign back to should pop, and then actually make the visual line up with that. Okay? So then in our else here, we'll say this dot try to push to tower 0. So I'm going to steal this else. And I'll tack it on all these other ones and just change the numbers. All right, so that's the try to push. Go ahead and run this. So we'll pop from tower 0. we'll push to tower 1, we'll pop from tower 0, we'll push to tower 3, so on and so forth. We can pop from tower 1, push to tower 3. Very illegal moves, but functional. All right. Okay, so now we're going to doctor up our, we're going to add some additional logic to our try to push. Now, we can always pop. There's no rules associated with whether or not we're allowed to pop off the top of a tower. Other than if we're going to pop, if we didn't get anything, don't flip the signs, right? But we don't need to, we could always pop. But when we try to put it into a destination, we need to be careful. So all this stuff, where's my push? Try to push. This stuff right here should only happen if the tower I'm trying to push onto, if it's a legal move, which means that my placeholder disk has a value that is smaller than the value associated with the peak of my destination tower. Now, when I peek at my destination tower, I might not get a real disk. It could be an empty tower, which means that I'm good to go. Okay? So I'm going to go ahead and first get the value, get the disk at the top of my destination tower. So I'll say disk temp is equal to this dot towers at bucket tower index dot peak. All right, so that will get me the top of the tower without actually removing the top of the tower. Okay, now all this stuff here is going to only happen inside of an if. So I'm going to say if temp is not equal to null, and so if it's a real thing, and this dot placeholder dot get size is less than temp dot get size. If both of those conditions are true. Now, keep in mind, and you haven't heard this in a while, but when we first talk about Boolean logic, we talk about programming languages being smart enough. For an and to be true, both sides need to be true, correct? If this is false, Java will not even try to check this side. Because we know that if temp is null, this is going to crash the program, right? Because I'm trying to ask a null value for his size. That's not going to fly. But we'll only actually check this stuff here if this first part is true. Make sense? Now, if you don't like that, you can certainly do this in two separate if statements. If you don't want to rely on that knowledge. Okay, but for an and to be true, both sides need to be true. Therefore, as soon as one thing is false, Java is going to give up on it. It's not going to check any of the other conditions. So if this is true, this says that there is a disk and the size is less than it. Now, we want to actually push the disk in under two separate, this says it's completely valid, right? But really, we also want to be able to push the disk if it is null. So I want to push the disk if temp is not equal to null. I'm sorry, if temp, I got to write this a little bit differently. Say if temp is equal to null, or, so I'm going to push the disk if temp is equal to null, or if the placeholder size is less than get size. An or says only one side needs to be true. So as soon as one thing is true, Java will just go. If temp is equal to null, that means we have an empty tower. We're allowed to go ahead and push. If temp is not equal to null, then it will check this other side. And we just decided that temp is not equal to null in that case. So we will be able to ask something like temp.getSize. Because we're only going to be checking this Boolean expression if temp is not equal to null. That make sense? So same premise as the and. Java's smart with the ors as well. As soon as it hits one true, it'll stop. So if I'm either dealing with the empty tower or the disk at the top of the tower is smaller than the, than the disk I'm trying to add, because I can add smaller disks on top of larger disks. So actually this is backwards, right? Oh, no. Placeholder is the guy I'm trying to put. Temp is the guy currently at the top. So if the disk I'm trying to place is less than the guy currently at the top, then it's allowed. So I'll go ahead and I'll push it onto the top, and I will change pop. We'll change push to pop, and also update my Boolean switch. But all that stuff only occurs if I was allowed to pop. And, well, if I was allowed to push, rather, in this case. All right. So we'll go ahead and run this now. We'll try to do some illegal moves. So we'll pop. Then I'll push. Then I'll pop. I'm going to try to push on top of this guy, and it's not going to allow it. Okay. Then I'll try to push here. It's cool with that. And I'll pop here. I'll push here. That guy should have been able to go on here.
You updated your sizes and make it all at 0.
Oh, thank you. Oh, thanks. Remember a while ago I said don't copy and paste? All right, so now the logic should work. So pop, push, pop, doesn't allow it there. I can push it there. Pop, I can push it back there now. Pop, push, pop, push. Bro, I played this game very poorly. It's among the worst ways of playing the simple version of Towers of Hanoi. All right. So does that fulfill the assignment? I didn't say I had to like scream about winners or anything like that, right? Yeah. Huh? Make toast. Maybe we should make some toast with error moves. Okay.
So we didn't need to use set next this, but we don't have to set next to.
Yeah, we did. Inside of tower last time, we wrote. Yeah, we wrote push. Yeah, I mean, so last time I wrote the whole stack data structure for you.
Okay.
So like you pointed out, the challenge in this homework was melding the two pieces together. All right, so did everything we just did make some reasonable sense? If you had to do it again, would it be easier? No, it would still be hell. Well, how long did we spend on the assignment? 5 hours? More? Less? Oh, you gave up before that? About what, 5 hours?
I know I tried my hours.
Anybody spend more than 5 hours? Who didn't give up? This low constitution. Okay, how many hours did you spend before you gave up? Okay, okay, that's not embarrassing. I spent 15 minutes. I looked at it. I said, "There's a Mario Kart tournament today." Is that still a thing? Do people still play Mario Kart? It's a thing.
Speed run?
I don't know. I've never actually played Mario Kart, but I have the predecessor. There was this game when I was a smaller thing, um, called what was it called? It was on the Atari. Yeah, it was it was a couple of years ago, and it was yeah, we had the little paddle controllers.
It's just a little old.
I remember the day I got my Atari. I had chicken pox. That was my present for having chicken pox. Well, actually, yeah. I mean, I was like 3 days into the chicken pox torture. Do people still get chicken pox?
Yes.
I think so. It's really uncommon.
Because there's like a vaccine now for it, right?
There has been for a while, but they probably
Yeah. So I don't. There wasn't a vaccine when I was a kid. It wasn't a thing. You had chicken pox? Yeah, that sucked.
I got it, but I didn't have it yet.
Okay. Yeah, it was always a thing. Like, who was going to get chicken pox that week? 'Cause they would yank you out of school. You know, the teacher would catch it. Teacher would catch it and yank you out of school. Because it's like contagious.
Yeah.
Yeah, because all of a sudden you'd have an outbreak, a chicken pox outbreak at the. You got it when you're pretty young, probably what, third grade ish, something like that.
It's better than getting the old.
Well, because isn't the same virus the whatchamacallit, shingles? Yeah, which I've had some friends who had that.
Do you have the immunity of shingles if you have chickenpox?
I don't know. I don't know if you have the immunity. I think it goes the other direction. I think you have the risk of having shingles if you've had chickenpox because that means I think it's the same virus. I think. I don't know, I'm just crossing my fingers. That's what I'm going for. Oh, so you're very lucky if you have vaccines for that now. Chickenpox sucked, but I got an Atari out of it. So and it wasn't even like the good Atari. Like the good Atari was the Atari 2600. I had like 4 versions of the Atari before that. You know, we had little stick figures on the screen. And then mine came with Pong. That was what happened to that generation. When you spend hundreds and hundreds of hours in front of Pong, something's bound to go wrong.
And now, like in my VR, I would just get bored.
Yeah. How many of you have played the original Mario Brothers? Not Super Mario Brothers, but the original Mario Brothers. I was in a video game magazine for like a, not like a worldwide high score, but like a pretty impressive score for like, a 7-year-old or something like that. You took the picture with the Polaroid at your TV screen. It's like 16 hours I played. Huh?
Submit to school the magazine.
Yeah, you mail it in there. You mail the Polaroid. Yeah, now you upload a video of your real-time gameplay. I was also in an episode in a issue of Nintendo Power for a game called Super Black Bass for how to always get the biggest lunker, the biggest fish. I had a hack. Yeah. Well, I mean, it was like not like a cheat, but like, you had to do a certain thing in the game using the game's normal mechanics, and you always got the biggest right kind of fish. Those were the days. That was also a Polaroid. The Mario Brothers one, I might have had I had to etch it in stone. All right. So let's push this guy. All right. So should I give you an impossible homework over the weekend? What day is today? Tuesday. Oh, for Thursday. Thursday. Today's only Tuesday? Oh my gosh, that's terrible. Should I give you an impossible homework for Thursday?
Probably no.
All right. So for Thursday, take my solution to Towers of Hanoi and add error messages for trying to push onto the wrong tower, add a counter for the number of moves, and then add and when I say error message, it's probably a toast. So a toast when you try to make an illegal move, a counter for total number of moves made. So basically every single time that you pop, count goes up by 1. Every single time that you successfully push, count goes up by 1. Then detect when there's a winner. That make sense? Yeah. So use the interface I've created here, add a couple of other things to it, and add some light logic. But then the assignment over the weekend is going to be just terrible. So if you actually want to start thinking about the assignment over the weekend, I'm going to talk about this next class. It's something called the shunting yard algorithm.
This does not sound fun.
Oh,
Shunting just something in negative word.
yeah, the shunting yard algorithm is great. So we're going to be creating this. So this is the, how many of you have ever heard of reverse Polish notation? Okay, so,
It's time to pack up now.
time to pack up. So remember in, what was it, in 200 probably, or was it 250 when you guys had the process expression homework assignment? Where you had to take in a string like 2 plus 3 times 8 minus 4, whatever, and then you had to parse that out into individual pieces. And I said you just had to do it from left to right. You didn't have to take order of operation into consideration. Somewhere in your last 2 classes, you had that assignment at some point. You don't remember that? All right. Well, regardless, that assignment is.
You don't have any background on it yet.
Well, now you have background. You know how to add. If I give you a number, if I say 1 plus 2 times 3, you can do that, right? If I say do left to right, no order of operation, because 2 times 3 would actually happen first, right? And then 1 plus that, so it would actually be a 7. No, we're just talking about math, just adding. If I gave you some things to add and subtract and multiply, you could do that as a person, right? Yeah, you could pull that off. Just as a human being, if I gave you some small numbers to add and subtract, you could do that. All right. Well, yeah, when I do that assignment, typically I say you only have to go left to right. So you don't have to take into consideration that multiplication happens before addition and that kind of stuff. And the reason for that is that's a very, very, very difficult thing to do. Okay? The shunting yard algorithm makes that very easy to do. So it actually sounds worse than it is. It's going to use a couple of stacks and it's going to use a queue. So next class we'll talk about a queue. We'll talk about how this algorithm works. We'll start it and then you'll finish it over the weekend. I promise you it sounds way harder than it actually is. It's not, it's a lot of removing from the front, deciding whether it should go here or whether other things should go over here. Kind of similar to what we just wrote. We just have some fairly simple rules associated with it. So if you wanted to start looking at it, you could. Questions, comments, concerns, bribes. All right, I will see everybody on Thursday. Remember, today, student, faculty, staff, Bible study, God and Grub. You get free lunch. Go down to the cafeteria, sign in, go get a tray, take it down to the terrace room. Also, the computer science get-together is on the 22nd, March 22nd. So about a month from now. Yeah, a little over a month from now, a month from Thursday. I'm going to make it mandatory for my classes. And what I mean by that is if there's not enough voter turnout without reasonable excuses, I'm going to give an impossible homework assignment. So it'll be You should add that to your calendar now. It's over lunchtime, so right after this class, basically, down the hall there. I mean, you get free prizes like iPads and stuff. There's no excuse not to show up.
Is that Tuesday or Thursday?
It's I think it's on a Thursday. Yeah. So mark in your calendar, March 22nd, from 11:30 to 1. I think is the time period for it. There's already some signs around the department. We had crappy voter turnout last time, which is, well, I know, whatever. People showing up to it, same thing. Well, there's no excuse for that. We have like good prizes. The department spends a lot of money on this stuff, and not show up is just ridiculous. All right. See everybody on Thursday.